Hello everybody, I'm Alexy Khrabrov, the organizer of SF Spark, and here we're on location at Nitro, where we have a very interesting meetup tonight about deep learning on Spark. And this is a very highly anticipated topic. We had about 230 sign-ups at the peak, and folks are really interested in this area. And today we'll also have Alexander Ulanov, who is a senior researcher at Hewlett-Packard Labs.
Hi, nice meeting you.
Yeah, it's great to have you here. So, tell us a little bit about Hewlett-Packard Labs. Why do you guys use Spark, and how did you come to implement your own version of deep learning?
Mm-hmm. Yeah, so in Hewlett-Packard Labs, I'm in the analytics labs. Mm-hmm. So that's a lab that actually does research in software in analytics. And our current goal is to come up with some new analytics methods or some techniques that will make our new hardware shine.
Okay.
So in particular, currently HP is developing a shared memory machine, which will have a lot of memory.
Okay.
And we are also planning to develop software that will take full advantage of it.
Okay.
Because right now we don't have a lot of such software. And deep learning might be one of the applications for this shared memory machine. And since we can use some of the existing platforms for it, so we don't need to come up with some new platform for deep learning or for something. So we can use Spark.
Okay.
Because Spark provides other means, like for data processing and for machine learning and for streaming and everything. So that's one of the reasons why we develop deep learning on Spark. So it's one of the analytics applications for the shared memory machine.
Okay, this is interesting, right? Because we used to have in the 60s shared memory machines. So the cluster is kind of recent development. Mm-hmm. So are you saying that you will have basically kind of traditional architecture where you have multiple CPUs working against the shared memory bank? Mm-hmm. Because how is it different from a mainframe? Is it a new generation of a mainframe?
Yeah, you can say so. Actually, one of the main advantages of this, actually one of the main differences from the mainframe is that this memory will be non-volatile, so it won't disappear when you switch off the computer, right?
Okay.
And that means that you do not load the data every time that you need to speed up, like when you use the memory. So it's one of the differences. And another is that the architecture is quite different. So I can't tell about all the details, but it's just completely different. Because it just has much more memory than you can imagine on a supercomputer or a mainframe. It's just orders of magnitude more. And it should replace not only the DRAM, it should replace SSD and HDD. So that's one of the differences.
Wow, that's really interesting. I remember, so you attended text by the way, right? So you're basically interested in text as well. So is this kind of are these different applications, or is deep learning work connected to your text mining interests?
Actually, it's not connected. I used to do a lot of research in text analytics for the recent 5 or 6 years. But then I switched more to like distributed machine learning. But I still try to follow the recent papers in this area. And I kind of wait until someone will come up with a really good application of deep learning for text analytics.
I heard such, I think Metamind has some interesting work, right, where they can do sentiment detection really well using deep learning. So maybe you guys can run some text analytics on your platform.
Yeah, that's true, but unfortunately it's not as good as deep learning for images, for example, or for speech recognition. So it's not kind of something extremely, which is like much better than previous approaches.
Right.
It is better, but it's not as good as I want it to be.
Okay. So deep learning for Spark, it's I think it's and generally distributed machine learning is hard because normally so you have these iterative algorithms, you have these gradient computations, and basically you need to know what the gradient is. And so how do you generally solve? Like, do you take advantage of this fact of this your new architecture, or do you just solve it in general case? What is your approach to deep learning Spark?
Yeah, so since we are using Spark and the main parallelization in Spark is data parallelism, so that we can like compute the gradient on separate nodes and then do a global update of the model. And there are tricky things with that because like the stochastic gradient, it's sequential algorithm, it's very hard to parallelize it. Then batch gradient does not work well for large data sets, but it's extremely parallelizable. So we are trying to find like the sweet spot between those two approaches. And the shared memory architecture just provides a very fast interconnect. So like in case of cluster computing, when you have network bandwidth and the model is very big, then you can spend a lot of time on those updates. Like, and since you may have like millions of iterations and those millions of updates, it will just spend enormous time. And the shared memory architecture, it will provide much faster update time. And basically what we are interested in is in finding the trade-off between the computation and communication.
Okay.
And definitely there is an optimal number of nodes for a particular task, after which if you add more nodes, the task does not execute faster and it can even decrease in performance.
Is there a specific number did you come up with?
We come up with some heuristic which are pretty close to the empirical results. So it allows you to estimate how many nodes you might want to use. And if you have a specific number of nodes, how much slower you would be comparing to the optimal case. So you can have such estimates, and they're pretty useful, I think.
Okay. So you presented this work in Amsterdam at Spark Summit Europe, right? So, and I think it looked like one of the most kind of interesting talks, to me at least, on the program. So what kind of feedback did you get? Like, is there a lot of folks using deep learning in Europe? What was your general impression? What kind of questions people ask?
Yeah, actually I was very surprised that there are so many data scientists. And all of those folks, they use Python and R.
Yes.
So they were mainly coming from that perspective. So that how can I easily use your deep learning implementation without a big effort of learning something new?
Right.
Because there are a lot of libraries for deep learning, and you can just use them. And Spark, it tends to somehow also develop in the area of like data scientists. When you have plenty of different machine learning methods and data processing things. So those people were asking about this simplicity. So how simple is it to try? So that was my main surprise, and that they are interested in Python actually. And we have Python interface for deep learning.
Okay.
So they can use it. So that's first very big impression. And the second one was that people were suggesting something like some interesting workarounds and approaches. Like they were suggesting to write a separate implementation for GPUs that will take full advantage of the GPU, and also to explore like other ways of communication. Yeah, that's was the second interesting outcome.
So on the topic of Python, this was recently interesting to me because I noticed, right, a lot of data scientists, majority of them are using Python and R, right? And so Spark is written in Scala for a reason. So as a kind of Scala community organizer, I'm always interested in how do we bring Python and R people into Scala? So what is your impression? Is it possible to teach a lot of data scientists to use Scala, or is it kind of safer to stay, with kind of some APIs in Python and explain it to these folks? But if they have to actually tinker, can they contribute? Can they fork you and work with your Scala implementation if they use not only Python? What do you think is a good strategy?
And my impression was that they don't really want to switch to something new, and they have very good tools with a lot of options and a lot of libraries, like SkyPy and others.
Right.
And I think they want just to use the same API, but at the same time to be able to use it on the scale, like without any visible switch in the code, just to scale it. And I think it's also one of the directions that Databricks guys are following.
Right. So do you provide basically equivalent Python API for everything else you do in Scala?
For deep learning, there is a Python API.
And is it as full featured as the Scala implementation?
Yes.
Okay.
Yes. Yeah, we tried to keep it very simple, so it wasn't hard to implement it. Although I didn't do it. It was done by the other guy.
Okay. And this is a joint work, right? Because we talked with Chang Romang. So it's a joint work with Databricks and other folks.
Yes, it's a joint work, and it's surprisingly that we didn't know each other unless we meet in Spark developers mailing list. And it enables us to collaborate. And it's really interesting because we have different backgrounds, we are for different companies, but we can come up with something. And it's beneficial for everyone, I think, as compared to that everyone will develop its own system or its own machine learning method, and it wouldn't be as effective as the collaboration of people.
Right, and we have a lot of deep learning libraries right now. So there was this funny post on LinkedIn today from O'Reilly saying that TensorFlow matters despite the fact that every 47 days there is a new deep learning library, right? TensorFlow has some important things about it. So what is your take on all of this, right? Basically, so we have Theano and we have Caffeine. All these things are kind of not really scalable, and then we have TensorFlow, which turned out to be not as efficient as some other things, right? And we have some other libraries. So how do you see your library in this kind of set of other libraries? Do you benchmark it? Do you plan to maintain it and make it the best library, at least the best library for Spark? How do you see your library evolving?
Yeah. So first of all, it's not a library, so it's inside Spark. So if you download Spark, then you have it.
Oh, you have it already?
Yeah.
Oh wow, that's awesome. So is it part of MLlib? Is it part of distribution?
Yeah, it's a part of distribution.
Okay.
So you don't need to download something else. If you have Spark since 1.5, then you have.
You have it.
Yeah.
All right, that's awesome.
Yeah, that's good, I think. And actually, a lot of people were asking me similar questions on the Spark Summit Europe, and I kind of come up with some good answers in that. Actually, if you're deep learning researcher, you would not use Spark because it isn't the right platform for doing research, at least right now.
In deep learning itself?
Yeah, in deep learning itself, because you need to have a lot of features, you need to have very efficient implementations for everything, and it's not for research.
Okay.
But there are two basically use cases that are appropriate here. So one of them is that production. So sometimes you can just train your model somewhere else and then put it into Spark and use it in production, and it will be scaled very naturally. So this is one option. The second option is that probably if your data resides in Hadoop or in Spark or in cluster, and it's expensive to move it to some specific machine that does machine learning, that does deep learning, and then move it back, then probably you will sacrifice some performance for the ease of use. And I think it's like a general advertisement for Spark.
Yes.
It's easier to use than. So that's the second one.
You stay within the same system.
Yeah. So that's another option. And also, what's also interesting is that we kind of work on the ways how to scale deep learning, and it's not a very simple question. And some other libraries, they just don't interested in that particular question. They are interested in like more features, like using GPU like 100%.
Right.
And our work is related to try to scale it, and it's a different, it's an orthogonal thing, but it's very important.
It's funny to hear for me, that somebody would not be interested in scaling, right? Because if you hear somebody explaining why deep learning became successful in our times, Andrew Ng explains that, if you want to build a rocket ship, you need a huge engine and a huge, tank of fuel. So the huge tank of fuel is data, and huge engine is scalable engine computation, right? Because you can build a deep architecture. So I don't know, like why would you not want scale?
Yeah, that's right. I'm not talking for all libraries, but like some of them, they're just not interested, like Theano or like Café. There are implementations that use Café, for example, and like try to put it on a cluster.
Right.
And
from Yahoo, right? There was some work on that.
Yes, and also from Berkeley. There is a recent paper. And I think that's an interesting line of work. But it's kind of at the same time it's kind of coming up with some new distributed platform, and I think that probably it's better to use some common platform.
Right.
Maybe I'm not correct here, but kind of try to use as much libraries as I can use, and if I can just use something without developing it, then probably it's a good way.
Right. So you developed that library that features in Scala.
Yeah.
So, and we talked about why a lot of data scientists use Python because they're used to it, right? But if you want to motivate them, right? Because you chose Scala to write deep learning for Spark, and Spark itself is written in Scala, right? So I think it's a reasonable effort to teach data scientists that they can actually do a lot of this stuff in Scala. And I wonder, like, how would you explain to your colleagues who did not use Scala with Spark yet? They may be kind of trying Spark with Python, right? But they may be curious, why is it in Scala? What is this Scala thing? How do you explain to them the advantages of Scala, and why do you think, it may be a good idea for data scientists to try Scala?
That's a really hard question, actually. Yeah, it's a really hard question because it's kind of sometimes it's really personal preference.
Yes.
Like you like Python for some reasons.
Yes.
Like you like Scala for some reasons. I can tell why I like Scala.
Yeah. Why do you like Scala?
For me, it seems more natural to write code in Scala because it's very functional, and it enables me to focus on writing the actual algorithm as opposed to writing a boilerplate code for something like something else. And the code looks very condensed, and at the same time, it's very readable. But you can say the same about any other language, actually.
Java does not look very concise to me.
Yeah, that's true. But at the same time, a lot of people are used to it, and like you can persuade them of using something else.
True.
Yeah, and I think it's perfectly okay to have like two APIs in Python and Scala. And then probably at some point in time, people just the people who didn't have background in Python, they will just start from using Scala.
But you use Scala for your own implementation, right? And you found that it's reasonable, right? So I think that's kind of to me, it's a pretty good evidence.
Yeah, that's kind of there is a small difference here because I'm actually as a developer, so
Right.
And data scientist is not a developer, right? So probably there is a difference.
Okay.
And you probably don't need all these Scala features for doing data science. Probably, yeah. You might want like very useful libraries with a lot of parameters, pipelines, and like things you used to have. But you might not. Not want to use all the features.
Right.
So it's a subset.
Which you can do now. You don't have to,
Yeah.
right? You can use kind of a subset of Scala which is roughly similar to Python, right? But it kind of already will give you probably better performance and some type safety and things like that. So that's kind of how I think I think. I think every data scientist can use collections, right? And kind of Spark is basically, as Martin Dorsey said, it's kind of distributed, Scala, right? It's the ultimate Scala collections.
Yeah.
So so it's just a DSL. Spark is just a DSL for Scala. So which allows you to work with big data.
So it's really an interesting question, and I think if people like use Python, we should provide them with the proper API.
Absolutely, especially if you're part of Spark, right? Because Spark provides people API in Python, Java, and Scala. R as well. Well, excellent. So thank you very much for sharing this.
Thank you.
We're looking forward to the evolution of your deep learning implementation. Let's see how this develops. Let's kind of see how Python people use it, how Scala people use it. Let's have you back once you make some improvements to it, and we're looking forward to your talk.
Yeah, thank you very much for having me here.
Thanks.